And now let's move on. And now we are thrilled to introduce Sonya Natanzon. She's here with us for a second year in a row. She's a seasoned engineering leader and software architect with extensive industry experience. Sonya's career has spanned various industries, with healthcare being the most rewarding and prominently featured in her portfolio. Her journey led her to focus on software engineering and architecture within the healthcare domain. Currently, Sonya holds a leadership role in enterprise software development at Guardant Health. And today, she will be talking about, it's a feature, not a bug, a step-by-step guide to architectural decisions. Sonya, it's yours.
Thank you for that lovely introduction, and good. All right. Early afternoon session, so everybody's awake, not getting hungry maybe. We'll start today with a story, and it's a story about two Booleans. In it, you get a quick primer on how a clinical laboratory gets your results to you. You'll see a little bit of code, not much, I promise, and there's going to be interactive parts. So those annoying interactive parts where you have to yell out answers, but the best answers will get prizes, so pay attention. So clinical laboratory, how does it work? How does it get your results to you? They test patient specimens, and some of them are very, very broad. They have a large set of tests, such as your blood chemistry, your cholesterol tests. Others get really specialized, and they test neonatal biomarkers, rare diseases, or cancer. Specialty or not, all lab work breaks down into the same set of domains. A lab gets an order from a physician, it obtains a specimen from a patient, it puts that specimen through some laboratory testing process, it creates a set of results, it generates a report, gets the report back to the physician, and bills for the services. So today's story is going to focus on two domains, and that is result creation and report generation. Result creation domain has a set of responsibilities, and really they boil down to it needs to detect and quantify a piece of data. In case of a test for a cancer patient, we examine a set of genes, we call it gene panel, to look for specific mutations that would have either targeted treatments or clinical trials. Results come back in a tabular format. You can think of it as an Excel spreadsheet where a mutation is either detected or not. Now, these results then go to a report generation domain, and that has its own set of responsibilities. It enriches data from external sources, sorts, filters, replaces controlled vocabulary with something human or a doctor can understand, generates some pretty graphics, and puts all of that in a file that goes to a physician. In short, result creation domain detects a mutation, and a report generation domain will filter through important mutations, and those that are actionable will go into a file. Detected is our first Boolean, and this is our first version of a test that goes to market and is very successful. Of course, nothing ever stands still. We do more research, and we get to a much broader gene panel, and we creatively call it V2. We now need a V2 report that's going to show results from that V2 gene panel, but we're working with a couple of constraints. First of all, we can't really change how our V1 behaves. This is now a test on the market, and it's regulated by a regulatory body. Second, we have, well, a big overlap between V1 and V2 gene panel. V2 is really a superset. So what we really need to do is we need to be able to differentiate which results can go on which report. Enter our second Boolean called reportable, which gives us the results that are specific to a V2 test. Well, how do we use that? Since we can't change the behavior of our V1 test, we continue to use detected for V1, and now for V2, we're going to show our results with a combination of detected and reportable. We made an agreement with result creation domains that reportable will get us V2 only results, and this now goes to production as our V2 test, and life is good. However, a year and a half later, somebody from result creation domain is saying that maybe not all results that should be showing up on the report are in fact showing up. So we look into it. We look through the two systems and analyze the behavior. And what we find is that for V1 reports, the behavior intended by result creation domain and behavior implemented by report generation domain is identical. We're using detected. But for V2, the behavior intended by result creation domain, which is to use reportable only, and behavior implemented are not the same. We're using now a combination of detected and reportable. So we know they're different. How different are they? Well, we borrow a page from our test team, and we look at the inputs and outputs. And what we realize is that most of the time, the values of our two Booleans produce consistent behavior between what was intended by result creation domain and what was implemented by a report generation domain, except for this one case. What's interesting is this is not a 25% chance scenario. It is maybe 0.01% scenario because of how the data falls out. And this is the big reason why it went unnoticed for so long, but has potentially big implications. A result does not show up on a report. So, of course, arguments between two domain leads ensue. I am that guy on the right saying that the system is behaving as designed, and you can probably guess what the answer to the question on the bottom is. You don't get a prize for it depends here. It's no. And because it's now an old decision, we go looking for people who worked on this. We find one guy who finds one Confluence page somewhere that's way too vague, and we collectively agree that it does not sufficiently describe either the problem or the intentions of the solution. Now we get to the interactive part. Why did this happen? How did we come to this? All right, I'll give you one. Incoherent naming. Detected, reportable, who knows what they mean? How do you tell them apart? Any others? Low probability is a good one, but we didn't know this at the time. What else? That's a hard one. We can talk about what that means to test these types of things in a healthcare setting. How about this one? Unclear intents. One domain intended something. How did they show their intents and record them? Entirely unclear. Fuzzy domain boundaries. Maybe one domain is doing something it shouldn't. Maybe we should move it in a different domain. This is a good one. Lack of versioning strategy. Had no idea how we were going to version these things. Knowledge leaking across domain boundaries, for sure. There's implied things that are leaking. All of those are why we got here, but in reality, this is the biggest reason why we were where we were. No clear and documented architectural decision on the behavior of the V2 system. So, small thing, couple of Booleans with potentially really big implications. Some time ago, I defined the role of an architect as that of a leadership role, and leadership in three different areas: people, technology, and thought leadership. If this is the role of the architect, what is the job of an architect? What do all architects do, despite some really varied job descriptions out there? This is the second interactive part. You can yell. Attend meetings, definitely. Lots of those. What else? They communicate, definitely, do a lot of that. I like that, make sense of things. That gets a prize. They document, yes, you're getting to the nut of this. No, perfect, where are we at this talk? You don't get a prize for this since this is the title of a talk, but yes, we're getting to this. Nobody said draw diagrams, I'm disappointed. All right, so the job of a software architect, whatever the industry, is to make architectural decisions. This is the common trait we all have, common skill we all have, part and parcel to our job. Why are architectural decisions important? We're still at the interactive part, so yell. Because they're hard to change. They're hard to change. They can be, yes. One-way doors versus two-way doors. What?
Decisions will go in the random way.
Say that again?
Some decisions, software will go in undecided way.
They have unintended consequences. Prize. What else? Sorry, you have to be louder. They are expensive to implement. We can get to a couple of them very quickly. They impact your quality attributes or abilities.
They tell you why you got where you are.
Say that again?
They tell you why you got where you are.
They tell you why you got where you are. Good one. That's a prize. All right, let's get through a few of these. They can affect your system's ability to change. That's an important one. They can resize your technical debt. If you look at these verbs, they're very neutral verbs. Resize, depending on the decision you make, can make the technical debt bigger, can make it smaller. Affect system's ability to change. You can make your system more rigid or more flexible depending on that decision. They can even change your career trajectory. You make good decisions, you get promoted. You make bad decisions, you get fired. But really, the biggest reason why architectural decisions are important is because they affect the long-term cost of a system. So I heard expensive to implement. Yes, they affect the long-term cost of a system. So under these circumstances, who even wants to make architectural decisions? They sound very dangerous and daunting and wrought with consequences like getting fired. They are all of those things, but there is good news. Decision-making is a skill, and as a skill, it can be taught, it can be learned, and it should be practiced to get better. Second, you're not doing this alone. If you are, you're probably doing it wrong. At every step of the way, you're going to engage with a group of people that will help you through that step and move you on to the next one. Last but not least, with architecture decisions, just like with anything else, you get better results if you have a consistent process. It's worth saying that nothing here is perfect. No framework or heuristic is going to be ideal, but you can avoid a lot of pitfalls if you're using a framework, and that is exactly what I'm here to talk about today. So we'll get through this quickly. I already had a wonderful introduction. I am a team leader. I'm a healthcare specialist, which you probably figured out from the intro and the example. If there is a word that describes me, this is a good one. I can't say that I don't like complexity. Complexity is just there, but I like to break down complexity until it's manageable. So without further ado, let's Decomplexify architectural decisions by breaking them down into 8 easy steps, starting with the first one, which is formulating a problem statement. Have you ever been in a room where there is a lot of arguments about technology? Let's use Azure, no, let's use AWS, and we need a document database, and Kafka solves everything. And you're wondering, what problem are we trying to solve? So engineers are detail wranglers. This is what they do. They can't wait to get into the weeds and start solving problems. But deep into those weeds, we tend to lose the forest for the trees. Sorry, very mixed metaphor, meaning we lose the bigger context and overarching objective. So before you go to any solution, formulate a problem statement. Foundational step to everything that's going to happen afterwards. Problem statement gives you a clear goal, a North Star where you can question every solution with, how does it help me address this problem? Charles Kettering, who was a head of GM research, said that a problem well stated is a problem half solved. So how do you state a problem well? There's a simple heuristic coined by Seth Dobbs that says that problem statement has either the good outcomes that aren't happening or the bad outcomes there are. That's it. That's all it needs, and we can practice it right here. Here's an example of a problem statement. We're losing $25 million annually due to bad billing practices. Shows a bad outcome that is happening. Makes it pretty clear where we want to get to, which is probably stop losing $25 million annually, or maybe get that number down to something business is willing to accept. A clear decision, you can question all of the solutions with, how does it help me reduce this loss? Here's another one. We need a new billing system. My immediate reaction to this is, why do we need a new billing system? What good outcomes will start happening or bad outcomes will stop happening if we have a new billing system? Unclear, other than we'll have a new billing system. So, what do we have? Well, this is a legitimate problem statement. Do we know what the solution is? Is it a new billing system? Or is it an upgrade of an old billing system, or maybe something else? Don't know. But there is a desired outcome, and you're free to go explore solutions to get there. And as for the second statement, yeah, you guessed it. This is a solution in search of a problem. If that's what you're finding yourself with, stop. You don't really have an architectural decision to make. You have a solution as a foregone conclusion. I don't know, maybe it's your boss's pet project, maybe it's something else. But there's no outcomes to drive to other than the solution that's already built into the statement. Getting a new billing system is the outcome. So now that you have a heuristic for creating problem statements, I'll give you one for recognizing solution statements. Anything that starts with "we need" is going to be a solution statement. That's it, really simple. Try this out now. We need to migrate from .NET to Java. We need a document database. We need to use microservices. Why do we need that? It doesn't work, right? There's no good or bad outcomes to get to. It's just a solution presented in a statement. You can still try to get to a problem statement by asking, why do you need whatever follows that we need? But ultimately, if you don't get to the outcome, stop. It's really difficult to be successful when all you have is a solution statement. All right, so I'm spending a lot of time on step one, which is the problem statement, and I recommend you do the same. You're going to want to use that problem statement through the life of the project, and you will need to keep coming back to it for a few different reasons. One is to justify whatever it is that you're doing to everybody, especially management, and ask for resources, budget, engineering hours, timelines. Second, validate assumptions and constraints. We'll talk about that momentarily with your stakeholders. And last but not least, set engineering goals. Whenever engineers start to go off and play with technology, you need to put that problem statement back in front of them to make sure that this is what their solution is aiming for. So I said, you're not doing this alone. Who is working on the problem statement? It's going to be a customer or representative of a customer, your product manager, your client services representative, account executive, so anyone who is a proxy for a customer. For more technical solutions, you work with your engineering leads, other technical functions. They will also help you with quality attributes for a customer-facing project. All right, so now that you have a problem statement, you can move on to the solution, right? Not yet. Before we move on to the solution, we need to identify the last responsible moment. In other words, you're asking yourself a question. When do I need to make this decision? But why even ask a question? Why not make it whenever you want? Why not immediately? We know that time is finite, project time is always way too short. Why not get a good head start? Well, early on in the project, we have limited information. We know that information changes over time, and it accumulates over time. So, assumptions made early tend to invalidate themselves, new assumptions tend to take place, and decisions made early are really risky. You end up with a lot of decision rework, and that, of course, adds to both timeline to cost of the project. So in that case, why not make a decision when you know absolutely everything about this? And, you know, when your information is most stable and most complete. Which, by the way, when is that? Never is good, but I was looking for at the end of the project. But yes, never is probably the right answer. Sometime on this project timeline, you start running out of time to consider all but one option, the one that fits into the timeline. Essentially, time makes a decision for you and eliminates important alternatives, so all you're left with is a default decision that fits. And we all know that decisions made by default are rarely the best ones. They're usually the ones that end up with a long tail of maintenance cost or rework and so on. So a different way of asking is, when do I need to make this decision by, is, are there alternatives? Maybe you don't have any. Maybe, again, you have a foregone conclusion, in which case, skip to step 7, record your decision, you're done. But if you do, you need to identify that last responsible moment. Last responsible moment is a strategy for delaying decision until the moment when the cost of not making a decision is equal and about to be greater than the cost of making a decision. What does that mean exactly? Real life example. You interviewed for a job and you got an offer. That offer is going to come with a deadline. You don't want to make that decision super early. Maybe you want to negotiate for more money. Maybe you wait for your current company to give you a counteroffer. Maybe you're waiting for that really annoying coworker to quit. But regardless, you're going to want to wait until last moment without passing the deadline, because that's when an important alternative of being able to take that new job is eliminated. Same in software. You want to delay commitment until the moment at which failing to make a decision eliminates an important alternative. You're trying to gain as much knowledge as possible while still preserving optionality. I see that play out a lot in buy versus build decisions. If you're considering something new and unknown, you want to learn as much as possible about it, understand all the implications, but not take so long that if you do decide to go with it, you no longer have time to implement it. All right, so what is last responsible moment really? It is the first, biggest, and costliest constraint for you to identify. It also is a mechanism for surfacing all other constraints and their relationships to each other. You notice you never talk about a single constraint in isolation. Your timelines, budgets, technologies, quality attributes, company objectives, all of these tend to intermix, and they all need to be considered in your decision. I personally love working with constraints. Constraints help precisely because they eliminate options. A field that's too wide open makes it really hard to pick a good direction, and constraints help narrow that path. but their interplay can be really, really challenging. It does remind me of Rube Goldberg machine. You press something here, something over there falls down. It gets complicated initially. So coming back to our example of a problem statement that we established, you're doing work with your stakeholders in your business as well as with your engineers to identify your last responsible moment and to surface all the other constraints that might be out there. I highlighted one for 6 months, feels important. Maybe the company will go under if we don't reduce that loss within 6 months. But ultimately, all of them need to be considered and they will shape what your solution will look like. All right, so now that we have our last responsible moment, we know it hasn't passed, we have other constraints. Time to move on to solutions? Not yet. Before we move on to solutions, we should establish a way to evaluate them so that we understand their fitness to the problem statement. What are we going to consider and what are we going to deliberately ignore? So I sit on a lot of design reviews, and the question that I always ask is, why is one solution preferable over the other one? And the answer I often get sounds like this. Well, this one is performant and this one reuses code. And I don't know about you, but it does not help me understand why one is preferable. Is performance important? Is code reuse important? If they're both important, why aren't we considering both of them for all the solutions? If they're not important, why are we considering them at all? So to avoid this type of apples to oranges comparisons, we need to establish a criteria by which we're going to evaluate our solution. Usually that criteria falls into 3 categories. 1, how does it solve the problem? Or does it solve the problem? How well does it solve the problem? It is always surprising to me how many solutions I've seen that don't address the problem, sometimes completely, sometimes partially. How well does it address the constraints? So we worked through a whole bunch of constraints and we need to make sure that they're addressed in our solution. Some of those are going to be more rigid and more important. Others will be more flexible, less important, but we need to look at all of them. And last but not least, how well does it satisfy the quality attributes or abilities? Now, those are basically constraints in their own right, but not the ones that business establishes. If you ask the business, do you want your solution to be performant and secure? They're going to say, yes, of course, we want it to be performant and secure. How performant, how secure, at what cost, with what trade-off? That is what you're helping establish and vet. There are others out there, maintainable, that was a good one earlier this morning. What does that mean for code to be maintainable? If I talk to the business about fitness function, they would glaze over. Oh, it means you don't have to hire 4 more engineers to keep this thing running over next year. This is the words they will understand. So, not all evaluation criteria are made equal. As I said, some are more important or more rigid, and others are more flexible or less important. How do you incorporate that into your evaluation? Use relative weights. That scale could be completely arbitrary. Pick a scale for yourself, and have it indicate importance and rigidity. The higher the weight, the more important or more rigid it is. And of course, you're not deciding on those weights by yourself. You're working with your stakeholders and business, and for the quality attributes, you'll work with other engineering function, your InfoSec, your DevOps infrastructure teams. All right, so coming back to our problem statement, we now have an evaluation criteria. You can see the relative weights available. The higher ones are going to be the more important ones that we want to consider. Everything else is more flexible, but still needs to be reflected in the solution. All right, so now that we have our solution criteria evaluation, time to create solution options, right? No, we got there. It's time to create solution options. It might seem like the most important part. It's actually the part I'll spend the least time on. Reason why is you're all leads, engineers, architects. You know your domain best. You're perfectly well equipped to come up with great solution options. A couple of things to remember as you do that. First of all, generate more than one option. A really sharp product manager once told me, if you can think of a one solution, you can think of more than one. Your peers, your stakeholders, your business will really want to know that you truly considered more than one option, not just your favorite one, not just a simple one that popped into mind, but multiple options. Don't go too far beyond 3. I find 3 to be generally a good number. Too many more tend to introduce analysis paralysis, and people tend to get lost in the nuance. The other thing that starts happening is you get variants of the main option. You get like 1B and 3C and lots of little ones. When that starts happening, do some work of elimination. Some of those subvariants will replace the main ones, others will go away completely, but the total number should hover somewhere around 3. All right, last but not least, make sure you have one radically different solution. The work of creating radically different solution helps you keep yourself out of your own and somebody else's biases. Maybe you already had a favorite tech in mind. Maybe your boss is bringing their favorite vendor or platform to try to solve it. Putting on the table something radically different helps bring people together to start thinking out of the box quite a bit more and consider things from different angles. Of course, as you're doing this work, you're doing it with the stakeholders and with engineers. All right, so coming back to our problem statement, we came up with 3 different solution options, the last one being a radically different one. If you look at it, it's not even a technology solution, it's a people and process solution. We think that with one more role and a little bit of training, we can eliminate much of this loss. So now that we have our solution options, is it decision time? Well, not just yet. Before we get to decision, we want to get some advice. I made the steps separate, but in reality, what often happens is it gets pushed together with solution option creation. You tend to get advice in the process as you're creating and eliminating solutions. Before we talk about advice, quick reminder, this is your decision. Your organization empowered you to make that decision, or maybe you're that accidental architect and it fell in your lap, but regardless, this is your responsibility to make that decision. But of course, those decisions are wrought with consequences, and you're accountable for that decision and its consequences. There is good news. You can and should seek advice. Advice is interesting in that it's more effective than when you ask for input or feedback. When you ask for that, you tend to either get very strong opinions and people start thinking that it's now their decision, or you get some really fuzzy stuff because people are not necessarily good at providing really good, honest feedback. However, when you ask them for advice for their lived experience and how they dealt with a particular situation, you tend to get much crisper and more useful information. Who do you ask? There are 2 groups of people that you should ask. First, those that are meaningfully affected by your decision. So let's say the team that has to consume the changes to the API, the client services person who's going to have to explain the workflow changes to the user, a marketing person who's going to have to prepare promotional materials to the product change that you're making. The second group is those who have expertise in your design space or in your decision space. So maybe this is somebody who understands the technology. Maybe it's somebody who's gone through a similar decision. They stepped on a few landmines and they learned along the way. That list of people can actually get pretty long. All that indicates is that your decision is important. The longer list, the more important the decision. Don't shortcut that process. Last thing you want is to find out that you didn't ask someone and now they can't consume the change that you're proposing, or if you're in regulated space, you might be stepping on some local laws. What do you do with all that advice that you get? This is the lovely thing about advice. You don't actually have to use it all. Some of it is not applicable. Let's say that person with expertise with your decision space, maybe they had a huge budget and a short timeline. Your situation is different. But what you do have to do is you need to seek a broad range. You need to really hear it and process it. And you need to record it and say why it is or isn't applicable to your situation. That's it. So what I described just now is not my invention. This is an architecture advice process by Andrew Harmel Law. I really, really like that process for making sure that we really hear any advice or any information out there and process it, but retain the agency for decision-making with the architect. All right, so now that you've been advised, what's next? Well, we are going to perform our trade-off analysis on the solution options. The good news is you already have all of that structured criteria to evaluate your solution options. The next thing you need to do is assign yourself a scoring system, and that, by the way, is again completely arbitrary. It can be 1 to 10, 0 to 5, -3 to +3. Then you go through each criteria and you score it, while explaining why you assigned the score that you did. This is the area that often becomes a hotbed of debate, and what occasionally happens is that you actually end up reevaluating the weights that have been previously assigned to a particular criteria. Hey, we thought this budget was flexible, turns out it's actually really fixed, we must fit into this number, so it becomes a lot more important. So remember our problem statement of losing $25 million annually. Here are our solution options. And as we go through the evaluation criteria and assign scores, this, by the way, isn't all of it. I just picked 3. Otherwise, this slide gets a little too busy. And when we look at our weighted scores, there's something interesting here. Our people and process solution scores about the same as an upgrade and retrofit of an existing billing system. The biggest, and looks like the best solution, is still the new billing system, but we could get it probably about the same bang for the buck, maybe even better, if we just do a little bit of training and maybe introduce a new role. We can do that faster than any software solution, and we can probably buy ourselves some time while we put in a more long-term but also long-running solution in place, our new billing system. So, now that you're equipped with some really valuable insight from your trade-off analysis, now it's decision time. By now, a recommendation has most likely emerged from your trade-off analysis. Sometimes a couple of options are really close, sometimes there is a more obvious winner, but regardless, there comes the point of a decision. You've done all the work, you can show your work, and I'm sure by now you have an opinion of what the right thing to do is. So, go with that. Once made, record your decision. Now, a lot has been said about architecture decision records and their importance, so I'm going to be really brief here. Why are architecture decisions important? I think this is almost the last interactive part, so go for it. Lots of those things. Record keeping, communication, try to combine those together. And this is a hint. So remember this situation from half an hour ago? It's so that stuff like that does not happen. And you have a good answer to that question on the bottom. You can find out why. But let's talk about why they're important. Remember that architecture decisions affect the long-term cost of a system. The decision record is not important now that you're making it, that you're taking that decision. The architecture decision record is important when those long-term consequences kick in and people start wondering, why was that decision made? The record obviates the why, and It helps all of those that come after you change those decisions without having more unintended consequences. Basically, it lets them learn from your experience without having to go through your experience. They can see the long-term implications of your decision, the condition under which decision was made, and they can now pivot and change to another well-informed decision. Of course, in order for that to happen, you need to write it down. There is good news, of course. All the previous points led you here, and if you have been writing things down all along the way, which I really hope that you were, you should have most of your architecture decision record built up. I am not going to show you a template. There's lots of templates out there. Since apparently the theme of today is mention another speaker, I want to make sure to mention Jackie Reed's new book. She has a lot of good stuff about architecture decisions, so please take that, read that. But they follow a pretty standard pattern. They will have your problem statement, your constraints, your trade-off analysis, all of the input and advice that you solicited. You'll need to add a few more things, though. First of all, the decision that you made, the reason why you made that decision, but very importantly, positive consequences that you expect and negative consequences that you accept. Decision is always a trade-off, no matter what. And you want to be really, really clear about the trade-off that you're making in that record. So I said I wasn't going to show you a template. If you really need one, this is a very, very cute, fun one that you can use for life decisions. Has all the requisite parts: problem statement, last responsible moment, trade-off analysis. And oh, by the way, this is the prize for those of you who have gotten prizes, so come find me at lunch and grab the template for yourself. All right, so congratulations, you made a decision. Be confident, stand behind it. Nothing worse than flip-flopping on decisions. We talked about decision rework and how much it adds to everything. It might have been a hard decision. You might have gone against popular opinion. You might have gone against your boss's opinion. But regardless of that, decision should be fixed so that development can move forward. However, there are times when you have to reevaluate your decision. This last step is conditional, and the condition under which it happens is when material new information comes to light. What is material? Material is anything that you would have taken into consideration for your decision, anything that affects your steps 1 through 6, that is material. Yet another reason why it's important to write everything down, including your advice. Maybe you missed something, but maybe there's another real constraint that emerged while you weren't looking. I recommend going all the way back to the problem statement. Make sure you pressure test the problem statement, and then go through all the rest of the steps in a much more abbreviated format, where you take this new information and see if it changes any pathway that you would have taken along those steps. All right, so with that, you now have a framework with 8 easy steps that, with some practice, should make your decision-making process a lot less daunting. Thank you, and I hope all of your decisions are easy.
Thank you, Sonia. We love your presentations. Let's start with a funny question.
Sure.
So from 1 to 10, how much do you like TV show Silicon Valley?
So I'll answer that with a statement and not a number. You can see this as an inspiration. I recently rewatched it. I watched it for the first time when it just came out, and I rewatched it, and I felt a much deeper appreciation now that I have more experience for everything they went through. So I think it's a very, the show is basically like many jobs that I've been through.
Okay, so how much does this process take from start to finish? In practice, what is its success rate?
So the process can range. If there are really big decisions, like buy versus build for a platform, it can take months. If there are small decisions, I've seen it take anywhere between a few days to a couple of weeks. Again, size of the decision here really matters. The practical success, I don't look for checking every box. Again, this is architecture, there's no dogma here, but if you have the process in your head and you make sure that you go through everything applicable, I find that it's actually quite successful. People think of a lot more of these various aspects of it.
Thank you. So how could we try to calculate the point of last responsibility moment? Is it subjectively calculated, or are there any proper metrics or mechanics to help identifying it? Otherwise, it seems easy to fall into paralysis by analysis or take decisions too soon.
It is extremely subjective, but what I find helps is if there's any business goals that need to be accomplished, usually there are. A lot of things are driven by things like competitive pressures, industry events. That really helps you work your way to the last responsible moment.
Okay. Have you ever had a situation where you changed your decision after initially choosing one?
Yeah, I have actually. I recently had a big argument with one other domain lead saying, we will do this work in a different domain, you don't need this information. And then a few weeks later, they were talking about another business case, and I'm like, I think they really do need that information, so we might have to reevaluate what we did. So yes, it happens more often than I care about.
And how you enforce following the written decision you made?
So I don't enforce it, but after a few times of feeling the pain, apparently, we humans learn by negative stimulus a lot better than by positive stimulus, and not having a decision record. I think it's a well-known thing to go create an architecture decision record, or to basically write things down. This is all I say, is write things down. A couple of times I've refused to allow a project to move forward until things were written down. I found that there was a lot of talking and nothing written down, and I said, we're gonna all stop now and won't do anything else until we write it down. So that helps too, but I am in a unique position of being able to do that once in a while, use that hammer.
Okay. That approach seems very complicated and adds a lot of overhead. Can you recommend some ways of making it faster, simpler?
This approach is not meant to add overhead. And if there's some steps that aren't applicable, don't use them. Again, not a fan of dogma. Look at it on a situation by situation basis. But what I will tell you is once you've practiced it a couple of times, it actually goes pretty fast, because you can do this with people in a room sometimes within a day.
Okay. Where do you save ADRs that affect many microservices?
For us, everything is Confluence, for better or for worse. If it's searchable, thankfully, so we can find things most of the time, but the only thing that I'll recommend is use good keywords so that it's searchable. I find that code repository is not the best place, because it's not just the coders, it's also the business who wants to see this, and they're not gonna go to your GitHub repo.
Okay. Regarding problem statement, isn't the approach you described just if it works, don't touch it approach, but rephrased?
I guess I'm not sure I follow how it's if it works, don't touch it. Sometimes it's a good strategy, sometimes you have to. Time comes to change certain technologies, move forward, you have to touch it.
Okay. Should we use some software architecture decisions to win more time and delay the last responsible moment of other architectural decisions?
If you can, sure. I find that last responsible moment kind of lands naturally, so delaying it artificially or pulling it in artificially doesn't work. I would just let it play out.
How soon post-implementation bug becomes a feature?
Sorry, say that again.
How soon post-implementation bug becomes a feature?
How it becomes a feature? First of all, it needs to be discoverable, and it has to have a positive side effect. You know how users will find a way to do what they need? So if they discover something useful for themselves, they will use it, and then you will have a real hard time taking it out of the system, even though it was a bug, because now they're using it for something practical.
Okay, if I create 3 possible solutions options for each solution, company cost for architects increase and multiply by 3, how can I justify it with our CEO? I repeat again. If I create 3 possible solutions options for each solution, company cost for architects increase and multiply by 3, how can I justify it with our CEO?
So with C-level communication, you always need to tie it to business outcomes, no matter what you do. If you just talk technology, it doesn't work. So it becomes incumbent on you to understand the business and be able to clearly state what positive outcomes you're going to gain with that solution.
Who are the stakeholders that need to be involved in the process you described? Who do you consider absolutely necessary and who can be actually skipped?
I don't want to bore you with roles and responsibilities matrix. Usually for anything of an important size, there will be one. So there'll be people who are responsible, accountable, and the ones that are just informed. That should be easy. For others, for smaller decision, you usually know who your business is. The person who brings you the problem is usually the stakeholder that you're going to want to work with. If they're too high level, sometimes you want to bring people with, who are with hands on keyboard, and they will experience the impacts of your solution or your decision. So work with those.
And last question. If you see your decision is failing, would you revert changes already made and start over, or try to fix everything on the fly?
On the fly is a hard statement, but I think reversing decisions is hard. I'll give a very quick example of, there was one platform that tried to change an authentication methodology that they were using, and it was a spectacular failure when they launched. Like, users could not log in, and they couldn't revert it. That's hard. They should have had a mitigation strategy, and so next big technical change they learned, and they had a parallel strategy to make sure users are not affected. But I think reversion of certain decisions is just too hard. They're one-way decisions.
Thank you, Sonya. It was a pleasure having you.